My paper today is going to be about serum companies and the lithic analysis protocols that they use specifically for debitage. Every serum company has their own analysis protocol for everything, including debitage. And they're widely varied both in effectiveness and replicability. They tend to become, over the years, more complicated because we deal with such a variety of different types of sites in different geographic areas. And a lot of them are decades old, and they just kind of aggregated into these massive things that don't typically get looked at very often. So my presentation today is about NewSouth's effort to rewrite our debitage analysis protocol. It was part of a lab-wide update of our analysis protocols for everything that we did in 2010. So Shawn and Scott Keith and I evaluated our previous system and how it was used by our archaeologists, both at the survey level and for testing and data recovery. We came to two inescapable conclusions. One, it was not producing good quality data. And as a result, it was being largely underutilized by our archaeologists for site interpretations, especially at the survey level, which is the most common way we produce data. In fact, it was so complicated that we, after much arguing, just scrapped it and rewrote a new one. So we had two basic goals for our new protocol: replicability and data potential. This is our old system. This is a very embarrassing slide. It's quite a mess. It has 9 flake types that are defined by 13 attributes. The flake types are a variety of technological and behavioral terms. The attributes are a variety of quantitative and qualitative measures. And the results we were getting from this analysis were boiled down into the flake type. So the attribute data was not even being recorded into the inventories. So we didn't even have access to it. The unavoidable result of a system like this is the level of complexity forces an analyst to try and simplify it themselves. So the actual person looking at the debitage can't keep all this stuff in their head at one time. So they started just naturally sorting artifacts by 1 or 2 easily identifiable attributes, usually dorsal cortex, overall size or thickness, the overall shape or longitudinal curvature, things that are easily identifiable because they're under budget constraints and they're having to move through this stuff. They can't take all this time. The results that we got from analyses like this were not replicable at all. In addition, the list of flake types was born of these multiple theoretical frameworks, and it produced categories that were not mutually exclusive. So one flake can fit into multiple flake types, depending on who analyzed it, or the same person analyzing the same flake 10 days later. So it's easy to see why archaeologists had a difficult time making sense of this data and using it for site interpretations. So the old system contained flake types that were not mutually exclusive, they were not replicable, they couldn't support inferences based on statistical probability, they contained a mixture of technological and behavioral categories based on a mixture of quantitative and qualitative measures. They produced minimal amounts of fairly unreliable data. With so many flake types and attributes, there were literally hundreds of thousands of possible outcomes for each flake. Lastly, the analysis and curation were both slow and expensive. Some curation facilities still have guidelines that require artifacts to be bagged down to your base analytical unit, which with this system meant 1 flake per bag, pretty much. It was impossible to even do it. So, as I said, the goals for the new system we created were both replicability and data potential. In order to be replicable, debitage analysis has to be simple. We wanted a system based on the identification of a single attribute at any one time during the analysis, what Andrzejewski called a monothetic approach. We also wanted nominal attributes that had mutually exclusive states. Recent tests on lithic analysis replicability have shown that even among expert lithic analysts, attributes with too many possible states are identified with only around 60% accuracy, which is almost random. So one feature of the new protocol was to reduce our analysis decisions down to yes or no questions whenever possible. We also developed a lithic analysis training class for the lab staff and also a class on the interpretation of the debitage analysis results for our archaeologists. For data potential, we made sure that we used both exhaustive and mutually exclusive categories for our debitage, for our flake types. We wanted something that can be used with various sample sizes, not just for large samples from our single component data recoveries, but also for the small temporally mixed assemblages that we typically get at the survey level. We eventually decided that platform remnant morphology was our best bet as a base analytical unit upon which to structure the analysis. I went through several large projects before we came to that realization. Platform remnants are a data-rich attribute of a flake. They're not only ubiquitous on all flakes, but they also contain the point of applied force that produced the flake. It's been said that flakes are a perfect artifact for interpretation because they're a result of a single human action at a single point in time. And the platform remnant of a flake is the point at which that action is the most observable. So this is our current system. It's much simpler. It has only 3 debitage categories and only 3 basic attributes. This is the base level of analysis that we do for all the debitage that comes through the lab, whether it's survey, data recovery, whatever. It's much simpler and it's easily expandable if necessary. We kind of have like a a la carte menu of debitage attributes that we produce, so the archaeologists have a list of debitage attributes and what their potential is for interpretation. So depending on what their research goals might be for a particular site, especially at testing and data recovery level, what are they looking for? And then they will talk to one of us and decide which attributes, if any, they want to add to the analysis for the general debitage or for a portion of their analysis. We train the lab analysts to identify all these additional attributes, should they be required. We still, in addition to this basic lab analysis, conduct detailed lithic attribute analysis that Shawn and Scott and I will do that sometimes involve 10, 15 attributes. So the raw material types, we try and simplify it as much as possible. The old list that they had in the lab, when I pulled up the spreadsheet of them, they had a general and specific raw material type, and the specific raw material types was hundreds of raw material types, some based on color, some on the rock characteristics, some on geographic location. It was just a mess. So we tried to boil it down, and we still try and use local types whenever possible, but only at the simplest level we can. Most of the time we just stick to very simple categories: chert, quartzite, rhyolite, things like that. For our larger projects, especially for testing and data recovery, our lab staff who will be doing the analysis are always part of the field crew. So they see the rock and they see where it's coming out, and they see these flakes. They dig them up for months at a time before they actually do the analysis. So they're familiar with the local materials. We also collect raw material samples whenever we can for a comparative collection. So this is the decision-making tree for our very basic analysis. It contains only 2 yes or no questions, and this is how we get to all our flake types. Is there a discernible interior surface? Yes or no? Is there a complete platform remnant? Yes or no? We sort all the debitage into 3 categories based on those 2 yes or no questions. Triangular debris and flake fragments, we will analyze the raw material, and sometimes we'll weigh them by provenience if we think we can get something useful out of it. For the flakes, we do an additional step, which is to look at the platform remnant type. So for our very basic debitage analysis, we have more types if we do the detailed stuff, but for the basic analysis, we have 4 platform remnant types that we sort flakes into. Again, these are a series of yes or no questions. Does the platform remnant contain cortex of any amount? Yes or no? If not, does it contain only a single flake scar? It's either 1 or more than 1. Then we have an unknown category, obviously, for things like crushed platforms or double struck platform remnants. So the benefits of our current system were noticed almost immediately. Analysis was much faster, much cheaper. Curation preparation even more so. We're producing reliable data that we can actually use for statistical testing, those of us that still do that sort of thing. The results are replicable. They provide a strong basis for behavioral inferences and for site interpretations. And even for small mixed assemblages from surveys, we can produce useful data in most cases. So I'm going to go through a couple of project examples where we started this up. This is 40MI-70. It's a large site that we did a day recovery on in Chattanooga around the Tennessee River. It has 6 temporal components in it. There's a later archaic lithic reduction site, which is the later archaic 1 there at the bottom. There are 2 later archaic campsites, later archaic 2 and 3. There's a middle woodland winter house with a refuse midden. The winter house is kind of off this way. The refuse midden is there in the profile. And then there were 2 mussel processing sites that were in different areas of the site, mussel middens. One was middle woodland and one was late woodland. This is our 12-meter block profile. We did a 12 by 3 meter block, and we cut through the levee perpendicular to the river so that we could see all the old cut banks. We recovered 30,000 pieces of debitage from this site, and almost all of them were from very well-defined temporal components. They were very stratified. We knew exactly how old the debitage was. Also, this project happened, the analysis for this project happened right as we were updating this Lithics protocol. So this was kind of a pilot study where right when this fieldwork stopped, we just decided to scrap the old system, leaving the lab stand there like, what are we going to do? So the general analysis for this site was the first large project we did under the new protocol. It also included a specialized lithic analysis that I did on a 23% sample of the debitage, about 6,500 flakes. So this was our pilot study. The initial analysis was done under the new protocol, but it was so early that we hadn't even trained the lab staff on the new protocol yet. In fact, at the time, we had not even finished our arguments about what to use as a base analytical unit, so we weren't even looking at the platform ruminant types, or we hadn't even settled on that as a base analytical unit yet. So one thing we did initially was compare the specialized analysis results there at the bottom with the original general analysis we did. And as you can see, the ability of the analyst to identify the flake's interior surface was pretty good, as indicated by the similarity in the percentages of angular debris versus flakes or flake fragments. The ability to identify the platform remnant, however, was not very good. The specialized analysis identified more than twice the percentage of flakes versus fragments, 78% versus 32%. And I expected some gap in those numbers because the proveniences I chose for the specialized analysis were from feature context and places where I expected less breakage, more whole flakes. But I didn't expect it to be that large. After the lithics training, we decided to redo the general analysis for the site. And the number of identified flakes jumped from 32 to 55%, which closed about half the gap between the original and the redo. So this is a lot closer to what I expected for the analysis. And this was just their first attempt after the training, the lithics training that we did the lab staff. They've gotten even better in the intervening years, but you can see the effect that it had, it almost doubled their effectiveness. As far as the way we use the data for this project, the debitage told us a lot. There are abundant primary and secondary sources of high quality lithic material right near this site. This site's in the Ridge and Valley, and there's a 500-foot escarpment on both sides of the site that is mostly Fort Payne Formation. It's got some St. Louis Warsaw at the top. Both of those produce very high quality chert. It's in every stream bed. It's in the river. It's primary sources on the cliff faces themselves. It's in the debris at the bottom. It's everywhere. So there was no lack of available good quality material at this site. Because of that, there was almost no variation in the raw material types, the frequencies of raw material types in any sample we looked at. They were all 99.9% high quality chert. Second, due to the fact that the site was deeply buried by alluvium, there was very little post-depositional disturbance from erosion or anything. The site was, every component was pretty much buried after it was abandoned. There was a little bit of erosion of the cut banks that we could see, but for the most part, we had very intact deposits. Interestingly, many of the lithic attributes we recorded for the specialized analysis showed little or no statistical variation between components, despite the known differences in site function, prehistoric activities, age, all of it. Some of these included size, weight, completeness, dorsal cortex, and termination type. No matter what component we looked at, where we pulled the sample from, the frequencies were almost statistically identical. There was, however, considerable variation in a few attributes like platform remnant type is one, and error correction rates. So our assumption was that the lack of raw material variation and the lack of post-depositional disturbances were the reason for both the lack of variation in some attributes and the inclusion of variation in other attributes. Attributes like size, weight, and completeness seem to be greatly affected by post-depositional processes. So they didn't vary at all because we had very little of that. We had a few exceptions. The flakes we got out of the refuse bin, for example, were biased toward larger, heavier flakes, which is probably because they were cleaning up around the winter house, either sweeping or picking up stuff by hand. You tend to get the bigger flakes. We also had increased breakage or less completeness in some of the samples that we're getting from the occupation surfaces, probably from trampling. The termination type and dorsal cortex appear to have been greatly affected by raw material variation. So we assume the lack of variation in the termination types, most of which were nice feather terminations, was a result of the fact that all the chert being reduced was very high quality stuff. The stable numbers for dorsal cortex, of which very little was found, likely a result of quarrying from nearby lithic sources, which are very abundant. So raw material availability and post-depositional processes obviously have a huge effect on the frequencies of some of these lithic attributes. Seeing the variation in platform remnant types throughout the assemblages with little or no variation in raw material or post-depositional processes showed that as an attribute it can provide useful data even without these familiar biases being introduced. It made us a little more comfortable in having chosen platform remnant type as an analytical unit. So another project is the Hale Gold Mine. This was a series of data recoveries we did at 4 later cake sites at the Hale Gold Mine in South Carolina. The Hale Gold Mine is a series of connected ridges with primary and secondary sources of quartz and chert and secondary sources of metavolcanics. The debitage from different components at these sites showed several similarities suggesting quarrying behavior. All the samples were dominated by a single raw material type. Not all the same. Sometimes it was chert, sometimes it was quartz. And each site you went to had 90% of something. All of them contained high percentages of flat platform remnants and very low percentages of faceted or cortical platform remnants. In general, the flat platforms typically indicate some form of earlier reduction. So based on the context of the samples and the analysis results, we think they were probably extracting the chert and quartz from primary sources, actually digging it up or prying it from bedrock exposures, which explains the lack of cortex on a lot of the platforms. They were bringing that material to these small campsites that we're finding and doing initial reduction, which is producing all those flat platform remnants on the flakes. So in the case of these data recoveries, the analysis highlighted that the same procurement and lithic reduction behavior at multiple sites with different age ranges was visible just through the platform remnant type. It showed a continuity of behavior through time, just using a single attribute. The next one is a big survey that we did at Fort Bragg. It was a 2,900 acre survey. It had 103 sites, most of which were these low density lithic scatters that we always get, probably archaic campsites, temporary campsites. The entire project, even with 103 sites, recovered only 1,004 pieces of debitage, which is very low. There were only 3 cores found in the entire 2,900 acres, and 54 bifacial tools. So despite these very small sample sizes, they're assemblages that are probably temporally mixed and heavily eroded, there were some very remarkable similarities in the lithic analysis. Most of the sites contained a very high percentage of faceted platform remnants and very few flat or cortical types. They were extremely rare. Coupled with a lack of cores and local raw materials, the frequency suggests that the lithic reduction at these campsites was largely for tool maintenance, probably sharpening or maintaining existing tools that they brought with them. There was no evidence of raw material procurement, no evidence of extended occupations. So even with these limited phase 1 assemblages, a simple analysis of the platform remnant provided an insight into what folks were doing at these campsites and, more importantly, what they appeared to have not been doing. So we're obviously pretty happy with our new protocol. We're getting good, reliable data, and we're able to use it for site interpretations at all levels of investigation. And it ranges from a single site to an entire prehistoric landscape. In fact, the surveys have benefited the most, I think, from the new protocol, given their tendency to produce these low-density sites that contain nothing but debitage. Our general analysis is much easier and much faster. Depending on the number of proveniences and the specificity of local raw materials, we've seen increases in the speed of the analysis from anywhere from 30 to 100% for most projects. Curation preparations also become much simpler, and it's experienced comparable increases in speed. With the option of adding attributes when necessary, our analysis is a lot more flexible, and the collaboration between the lab staff and the archaeologists is greatly increased. Those few of us who are still willing to run statistical tests are able to actually include the debitage, which is typically the only artifact you end up getting that has sample sizes that are large enough to be conducive to those kinds of tests. The only thing I want to say is that it was hard to wrap our brain around the fact there's no correct flake type. Flake type is obviously, we all know, is a construction of our brains. We create them based on our understanding of the physics and the technology and the behavior that's behind these activities. It seems fairly logical that our typology should change as our understanding of both the physics and the geology and the behavior changes with it. So we're happy. Our new debitage protocol can be continually expanded and upgraded. We try and do that whenever new research comes out about lithic attributes and what their interpretive powers might be. And that's it. Thanks.